Solving cubic equations and inequalities, part 2. All right, example 3, using the rational root theorem. All right, it says find all the real solutions of x cubed minus 8x squared plus 11x plus 20 equals 0. So in the past, we would look at this and we would try to factor. Since there are 4 terms, we would factor by grouping. So if you group the first 2 terms, you can factor out an x squared easily. If you group the next 2 terms, you have 11x and 20. There's nothing easy, or there's nothing that you can factor out 11 and 20 to make that easily factored. So what we're going to do is look at another method of solving, which is called the rational root theorem. So the rational root theorem says if f of x has integer coefficients, all right, your coefficients are 1, -8, and 11. You got a constant term of 20. So it says if f of x has integer coefficients, so ours does, then every rational solution of f of x equals 0 has the following form. All right, so p over q. P are the factors of the constant term. Your constant term here is 20. And q is the factor of the leading coefficient. Your leading coefficient in this case is 1. So we can quickly say P equals 20 and Q equals 1. All right, so what does the rational root theorem tell us? It tells us that we can find a root by trial and error, basically. So what we're going to do is look at all the factors of the constant term. So what are your factors of 20? So we've got 1. 1 goes into 20. 2 goes into 20. 3 does not. 4 goes into 20. 5 goes into 20. 6, 7, 8, 9 does not. 10 goes into 20. And then 20 goes into 20. All right, so those are all the factors of P, and we're going to put that over Q. So if you see right here, P divided by Q. So since Q is 1, we're just going to divide each of those by 1. So we're going to have plus or minus. And basically this says these are all the options that it could be. All right, so all the options that x could be. So what do we do with this? All right, once you find these factors and you do p divided by q, your constant term divided by your leading coefficient, or the factors thereof, then you're going to look at testing possible solutions. So how are you going to do that? You're going to do that using synthetic division. All right, so we have 1 and -1. So you got 1 over 1, so that's 1, and then -1 over 1 is 1. So our first 2 numbers that we're going to test is going to be 1 and -1. So let's test 1 first. So if we take 1, we're going to do synthetic division, and we're going to pull out our coefficients, 1, -8, 11, and 20. Just like before, we bring down the first term, multiply. -8 plus 1 is -7. Multiply, and then add, and then multiply and add. All right, so since we got f of 1, okay, this is 1 is the number we plugged in, since we plugged in 1 for x, and we got a remainder of 24, that means that is not a factor, so it's not a possible solution. So we're going to go ahead and check the next one. So let's check -1. Again, we're looking at this first part here. We already checked +1. Now we're going to check -1. All right, we're going to do the exact same thing. We got 1, -8, 11, and 20. We're going to do synthetic division again. Bring down our 1. Multiply. Add. Multiply. 11 and 9 is 20. Multiply and add. All right, so this time we get a remainder of 0. All right, so we plugged in -1 and we got 0, which means that is a possible solution of this equation. So if we know one factor, okay, we know that -1, so we know our factor would be x plus 1. That's one factor, and we know that because we used the rational root theorem and then synthetic division to find that this remainder here is 0, which means that is a factor. It means it goes into this evenly with no remainder, nothing left over. And if you have this, then you can find the rest of the answer. So since this is 0, you know that this is going to be 1 less than your cubic. So this is going to be x squared minus 9x plus 20. And then from there, you can say, can this be factored further? All right, so x squared, running out of room here, sorry. And then what multiplies to give me 20 and adds to give me -9. So 4 and 5 multiply to give me 20 and adds to give me -9. Two numbers that multiply to give you a positive have to either both be positive or both be negative. Because the -9 in the middle, that tells us that both of these have to be negative. All right, so in the beginning, we found that x plus 1 is one factor using the rational root theorem. And then we know that x minus 4 and x minus 5 are other two factors. Now, in order to check this, all you have to do is take these three factors, multiply them together, and if you get this, that means you did this correctly. All right, so that's how you use the rational root theorem. Now, if we'd have checked 1 and -1, and both of these had a remainder other than 0, then you would move to the next number here. You would move to 2, and then try -2, and then try 4, and -4. Usually it doesn't take that many attempts to find a solution, but you can see here that negative x minus 4, that means 4 is a factor as well, and 5 is a factor as well. So you can see that the factors are all coming from your the factors of your constant term. And last but not least, if these three factors give you this, and it says to find all the real solutions, remember the real solutions come from setting the factors equal to 0 and solving. So x plus 1 equals 0. If I subtract 1 to the other side, that means the solution is x equals -1. X minus 4 equals 0, add 4 to the other side. And x minus 5 equals 0, add 5 to the other side. So x equals -1, 4, and 5. Those are your three solutions to this polynomial equation. Example 4, find all real zeros of f of x equals 4x cubed minus 2x squared minus 16x minus 7. So again, you can see that the first two terms, if grouped, could be factored. 2x squared could be factored out of that. But -16 and -7 do not have an easy factor. So this is not easily factored. So what we're going to do is, again, look at the rational root theorem. All right, so we're going to look at our P and Q. All right, so remember, P and Q come from your factors of your constant term. So P, your constant term in this case, is -7. Q, the leading coefficient this time, is 4. All right, so we're going to look at all the factors of that. So the factors of 7 would just be 1 and 7. And the factors of 4 would be 1, 2, and 4. So we got to put 1 and 7 over 2, 1 and 7 over 4. And again, all of these become plus or minus. Now, you're going to see that a lot of these this time are fractions. So these are integers or whole numbers, but this is going to be 1/2, 7 halves, which is the same as 3 1/2, and this is 1/4 and this would be 7/4. So a good way before you start doing synthetic division to look at all of these possible solutions, what you can do is graph the equation first, and that'll help give you possible or more reasonable solutions. All right, so if you go to y equals, I've typed in 4x cubed minus 2x squared minus 16x minus 7, and then in my window I adjusted it a little bit. My x minimum and maximum, I'm just going from -5 to 5 with a scale of 1 because I don't need a whole lot of x's. I just need to zoom into the graph that I'm looking at. My minimums, in order to see the bottom of my graph, I had to go down to -25, and my maximum is still 10. And I changed that to a scale of 5 since these are both multiples of 5, and it just kind of makes it look not so crowded with 25 little dash lines in here. Okay, so this is on a scale of 5. These are on a scale of 1. All right, so once you see that, you can see that the x values, where it crosses x, these are your solutions. I say possible. These are all your possible solutions. These are your actual solutions, and which one of these did that come from? So let's look here, and we can do second trace and 0. So we're looking for the zeros of the function. So let's hit enter. We're going to go left bound, and then we're going to go right bound. Usually, well, what did I do? Let's see. Graph, second trace. I guess I didn't read it. Enter. All right. Left of that 0, and then I need to be right of that 0. And it says this 0 is about 2.43. All right, so that's one solution. Let's go ahead and do that for the other ones as well. So second trace, number 2. This time we're going to scroll back. Doesn't matter which one we find next. Let's come all the way to the left side. So we're going to do left bound. We're going to locate this 0 here. So I'm left of that point. Now I have to go above that point or to the right of that point. And it zooms in and it finds that 0 at about -1.43. All right, and there's one more x intercept, which means there's one more solution. So x, let's find the 0. Let's go, this time I'm going to be above it to be left. I'm looking for this point right here now. So I'm above it to be left of it. When it asks for left bound and then right bound, you have to be left of the point, and then you have to be to the right of the point. So you see I scrolled down below that point, so now I'm to the right of it. It zooms in, and then if you hit enter one more time, it will say -0.5. So x is about -0.5. So we can conclude that -1/2 is a solution, and then 2.43, I would say that is my positive 7/4, and then -0.14, I'm guessing that's my -7/2. Again, you can check that. We can use the zeros, use one of the zeros, -0.5, that's going to be -1/2, and then see if that factors out. And then what you can do is, since these are irrational numbers here, they're not easily found, what you can do is use the quadratic formula to find the rest of that. So let's look at that real brief. All right, because I'm running out of time and I feel like it's sufficient to use your calculator to find these solutions, I went ahead and did this, but I wanted to show you the other method as well. So if you use synthetic division, you can see that this gives you a remainder of 0. You take these numbers here, that gives you your rest of your equation, factor out the 2, plug it into the quadratic formula. This is equivalent to this right here.